Next, you will learn how to identify whether the vertex is a maximum or a minimum. Here, I want you to copy down this entire section that is labeled Key Concept. I also want you to sketch the graphs, if you can, into your Cornell notes. It says the graph of f of x equals ax squared plus bx plus c, where a does not equal 0, opens upward and has a minimum value when a is greater than 0. So here, this is the graph where a is positive, a is greater than 0. The graph opens upward and it has a minimum value. Then it says it opens downward and has a maximum value when a is less than 0. So here's the graph when a is less than 0, when a is negative. It has a maximum value here and it opens downward. The range of a quadratic function is all real numbers greater than or equal to the minimum or all real numbers less than or equal to the maximum. So in other words here, if a is positive and our graph is open upwards, our range is going to be all real numbers greater than or equal to this minimum value here, because our graph is going to be greater than that value. Where here, when our graph opens downward and we have a maximum, our range is going to be all values less than or equal to this number because our graph is below this value here. So let's take a look at some examples. As soon as I can scroll right there. Example 4. Yes, I want you to copy down example 4, A and B and C into your Cornell notes. So example 4, we're going to be looking at the maximum and minimum values. And here, be careful, it says maximum and minimum values. Don't forget to find both coordinates of the vertex. The minimum or maximum value is the y coordinate. So before we learned that the x coordinate is the axis of symmetry, the y coordinate is going to be your minimum or your maximum value. So the vertex tells you two important things about your quadratic. So let's take a look at the example. It says consider f of x equals negative 2x squared minus 4x plus 6. Part A says determine whether the function has a maximum or a minimum value. Well, based off of what you just wrote down in your Cornell notes, we know that because a here is negative, a is negative 2, the graph opens downward, which means the function has a maximum value. Part B says state the maximum or minimum value of the function. The maximum value is the y coordinate of the vertex. So first, let's figure out what the x coordinate is. The x coordinate, remember we wrote this down in our key concepts, is negative b over 2a. Well, here we listed out that a is negative 2, b is negative 4, and c is positive 6. So just by using these numbers that we already know that were given to us, we're going to fill them into our actual formula. So when we fill in negative b, if b is already negative, negative b is going to be positive. So 4 over 2 times negative 2 because a is negative 2. When you type that into your calculator or when you solve that out, you figure out that the x coordinate is negative 1. So the x coordinate of the vertex is negative 1. So now to figure out the y coordinate, we're going to plug this negative 1 back into our original equation that they gave us. So here, f of negative 1, meaning we're plugging in negative 1 for x. When you solve that out and when you type that into your calculator and solve it out, you get that f of negative 1 is equal to 8. This coordinate, negative 1 comma 8, is our vertex. And to find the maximum value, we only need the y value. So our maximum value is 8. Our axis of symmetry would be negative 1. Our maximum value is 8. And this is all given to us from our vertex. Part C says state the domain and range for the function. Now here, I would actually like you to graph it in order to figure out the domain and range, so that would require us to use our calculator. So we're going to take this actual function and plug it into our calculator. I'm not going to do that in this particular example, but I will show you in another example how to plug this into the calculator and find the vertex and the maximum and minimum, but not on this particular example. We're just going to use the book and we're going to use our knowledge of domain and range. So here on this question, our domain is all real numbers. If you were to graph that out, we know that a is negative, so our graph would go downward. But since our graph has arrows, it means that our domain values, our x values, are going to keep going from negative infinity all the way to positive infinity. They're going to keep going on and on and on. So our domain is all real numbers. Our range for this problem, if we had this on a graph, our range for this problem, and I know this isn't what it really looks like on the graph, it's just Miss James's sketch. Our range for this problem would be a value that is less than 8 because our maximum value on this problem happened at 8. So our range is going to be all of the y values that are less than or equal to 8. And yes, I do want you to copy this down into your notes. In your notes, however, I want you to actually plug this equation into your calculator. You know how to graph this. Remember, f of x is already there. Just type this equation exactly how it looks. I want your sketch to be an accurate sketch. Do not copy down my sketch. Copy down the accurate, the exact sketch. Then I also want you to do the guided practice here. I want you to do the guided practice in your spiral. You're following the same steps that we just followed in this previous example.